Hello dear students. In this lecture, I'm going to discuss the question number 15 and 16 of the chapter on fluid mechanics. So, the question number 15 says, the pressure intensity is same in all directions at a point. Alright, so I think there is a misprint here. We can ignore the first two options and okay. So the question number 15 says, the pressure intensity is same in all directions at a point. All right. So let us say we have a fluid. Okay. And let us consider a point P, which is at a depth D from the free surface of this fluid. All right. So the pressure at the point P is same in all directions. All right. When the fluid is at rest or it is moving as a rigid body. That means in case there is a relative motion between the various layers in a fluid, then this pressure will not be same in all directions. The reason being, let us say that this layer in the fluid is moving at a velocity u and this layer is moving at a velocity u1. So due to this velocity gradient du, there will exist a shear force or the shear stress, which is given by this equation, right? So whenever there is a relative motion between the various layers in a fluid, there will be a velocity gradient. And if there is a velocity gradient in a fluid, there will be shear stress. So as a result, let us say at this point, the pressure is same in all directions in a scenario where the fluid is at rest. So as soon as there is a relative motion within the fluid, a shear stress will be created. And this shear stress will dampen this pressure in the opposite direction. So the resultant of this will not be same in magnitude as the pressure in the upward or the downward direction. So due to the shear stress or due to the velocity gradient, the pressure will not have a uniform distribution in all directions. So we can take the option D as the answer for this question, which says the pressure intensity is same in all directions at a point when there is no relative motion of one fluid layer related to the another. Because if there is relative motion, there is the velocity gradient, and if there is velocity gradient, there will exist a shear stress which will dampen the effect of the pressure, hydrostatic pressure in that direction. All right. Now let us take the question number 16. The question number 16 says that we have an open tank, all right, which contains 1 meter deep water. So this is water. And then this layer of water has a layer of oil above it, which has a specific gravity of 0.8. Water has a specific gravity of 1, and the depth of this layer is 50 centimeters. All right, so we have to find the intensity of pressure at the bottom of the tank. All right, so in order to find the intensity of pressure at this point P, we need to measure the pressure which exists because of the different layers above it. So we have a layer of water above it, we have a layer of this liquid having a specific gravity of 0.8. This is an oil. We have a layer of oil, we have a layer of water, we have a layer of oil, and we have a layer of atmosphere. And there is nothing about the atmosphere that is given in this question. All right, so in order to find the pressure intensity at this point, we have to take the effect of these three layers above the point P. So let us start from the first layer. So the pressure at the point P will be equal to the pressure due to the atmosphere, then the pressure due to the layer of oil, and then the pressure due to the layer of water above this point. Okay, since nothing is being said about the layer of atmosphere, so we can safely assume the pressure due to atmosphere as 0. All right, then let us take the layer of oil. We know, or we have to remember, that the pressure at a point in a fluid is equal to the density of the fluid times the acceleration due to gravity times the depth of that point below the free surface of the liquid or the fluid. Let us say we have a layer of water in this container, and we need to find the pressure at this point. So the pressure at this point P is equal to rho g h. All right, so the pressure at point P due to the layer of oil would be equal to the density of oil times the acceleration due to gravity times the depth of this fluid layer, this oil layer. The depth of this layer is 50 centimeters or 50 upon 100 meters. All right, so when you write this equation, we have found the pressure at the bottom of this layer. So the pressure at the bottom of the oil layer is the pressure is the density of the oil times the acceleration due to gravity times the depth of this layer of oil. All right, then the pressure due to this layer of water equals the density of water times the acceleration due to gravity times the depth of the layer of water, which is 1 meter. All right, so what we have done is, in order to find the pressure at the point P, we have taken the sum of the pressures above this point. The first pressure is due to the layer of water, which is this. Then the second pressure is due to the layer of the oil, which is this. All right, the pressure at point P is equal to the pressure due to the layer of water. The layer of water has a pressure due to the layer of the oil, which is this, and the layer of oil has the pressure due to this atmosphere, so which is comparatively zero in this scenario, because nothing is being said specifically about the pressure due to atmosphere. Let us simplify this question a little further. So we have the pressure at point P equal to, okay, now the density of the oil, we need to use the density of the oil in this scenario, but the density of the oil is given in terms of its specific gravity. And we have to remember that the specific gravity of any fluid or any liquid is equal to the density of that liquid upon the density of water. So the density of the oil equals the specific gravity of oil times the density of water times the acceleration due to gravity times the depth of the layer of oil, which is 50 upon 100, plus density of water times the acceleration due to gravity times the depth of the layer of water. So to solve it further, G equals 0.8, density of water is 1000 kgs per meter cube of water times the acceleration due to gravity. We can take it approximately equal to 10 times the depth of the layer of oil, 50 centimeters, density of water 1000 kgs per meter cube of water, acceleration due to gravity, and the depth of layer of water. All right, so let us solve it. Plus 10,000, so this is 4,000 plus 10,000, so the pressure is 14,000, all right, Newton per meter squared. How? Let us see. Let's take any component of this equation. Density is, the unit of density is kilogram per meter cube. Acceleration due to gravity is meter per second square, and depth is in meters. This is the depth. All right, so kilogram meter per second square is Newton. All right, then meter upon meter cube is meter squared. So that's how we have the unit of this pressure as the Newton per meter square, and this equals 14 kilonewtons per square meter. All right, so let us go back to the options in this question. So we have the intensity of pressure at the bottom of tank will be 14 kilonewton per meter square. So the option D is the right option. And we just need to remember that whenever we need to find the pressure at a point, we need to take the effect of all the layers above it, and the sum of the pressures of the layers due to the layers above that point would give us the pressure intensity at a point. We could have found the pressure intensity at any other point, say this point D. Then in that case, we should have considered, or we must consider, the depth up to this point, and the pressure at D would have been equal to the pressure due to the layer of water, due to the layer of oil, and then due to the layer of atmosphere. If any value was assigned to the pressure of atmosphere, it would have got added. Otherwise, we could safely assume that the pressure due to atmosphere is 0 in the situation. Thank you for watching.